So I'm going to talk about something that started out as really as more of a hobby than anything else, because I worked for FLIR for a long time, and I've always had a real obsession with imagery. I love pictures, and I love to do photography. I've taught photography at a commercial photography school. So I guess it was about 3 years ago, I decided to take a panoramic image of the Mission in Santa Barbara, and I put together a camera rig and started shooting images with it. So, hang on a second. I just realized I'm controlling this. So, the problem with thermal images is that they're low resolution inherently, right? I mean, the cameras today, the best cameras that we have are on the order of a megapixel. There's some bigger ones, but it's pretty much about a megapixel. So that's the state of the art in 2017, and it's hard to make a really giant sensor. We don't have commercial 16 megapixel thermal imaging cameras right now. They've made them, but they're so expensive and giant, they just use them on telescopes and things like that. So if you want to make a big print for wall art, you find that the images get really pixelated or blurry. All the images I'm going to show you are all taken with 3 to 5 micron InSb. I'm still waiting for some bigger SWIR arrays, which are coming, so I can do some giant SWIR panoramas. So this is a picture that has been used a ton in our marketing over the years. I took this picture 15 years ago with a 640 by 512 camera. It's a Chinook helicopter. It's a nice image, and it's really good for web content, but if you blow it up big, you really start to see the pixels. You can see the pixels on the front landing gear there. It's real obvious how pixelated it is. So if you try to print this thing bigger than maybe 2 by 2 feet or so, 2 feet wide, you really start to see some pixelation or certainly some blurring. So 1024 by 1024 is a lot better. And this is a picture of me firing a rifle with that, taken with that camera. And that image looks really good. And you could print that up to about 3 feet square, and it looks like a regular photograph essentially. But you can still see the pixelation when you zoom in on the top of that rifle scope, kind of in the center of the image. You can see I have a little inset of that. And then finally we have 1344 by 784. That's the biggest camera that I've used to date. There are some bigger sensors that are commercially available, but this is really about the limit. And same thing, you zoom in on it, like you zoom in on that detail on the side of the motorcycle, you start to see the pixelation. So when FLIR decided to move out of the buildings that we were renting in Goleta and move into a facility that we bought and that was being renovated, and the general manager said, I want some wall art for the walls. I want something that's new and different. So that's when I decided that it was time to take some really serious steps, do some big panoramas. So these panoramas are stitched together from lots of smaller images, and the software for doing the stitching has gotten really good. It's gotten to the point now where the images, you have 2 images that are side by side and they're a little bit warped or out of alignment. The software will figure out fiducial points on each image, and it'll warp them slightly to make the stitch really smooth and seamless. So I applied this technique using this software like Microsoft Image Composite Editor to images taken with that 1 megapixel camera using a long focal length lens. So the long focal length lens, you're looking at a small portion of the image at a time, and then you just step around in that scene and stitch together all the frames you get. So the camera's mounted on a pan tilt it's a precision pan tilt. It's got really fine motor control on it. And you shoot a relatively stationary scene from a very stable platform. So I can't really put this camera and pan tilt system on a mast up high. It's just too much vibration and movement from a little bit of wind and things like that. So what I usually do is I put it on a big tripod put some sandbags to stake it down and shoot from there. So these images ended up being really, really big. So here's the first rig that I used. That's a FLIR SC8303 camera. So it's 1344 by 784 pixels. And I put it behind a Janos 50 to 500 millimeter zoom lens, and I zoomed it all the way to 500 millimeters. So at that zoom, the field of view is, I think, is about 2 degrees wide. So you can imagine if you have a scene that's 50 degrees wide, you're shooting on the order of 25 images. So now that the field of view, the width is going to be 25 times the width of the image. So you're up to tens of thousands of pixels pretty quickly. And that really opens up a lot of possibilities for making prints, including, you got a giant image, you can go in and crop and take crops from that and then print those crops really big, and it still doesn't look pixelated. So the camera rig is sitting on top of a FLIR D300 pan tilt, and this is a pan tilt that has really, really precise gears. I got the slowest gear ratio I could get, and I had them tune it. I had the technician tune it up so it's like really cherry performance on it. Super low backlash and very precise movements. So it's kind of like a custom pan tilt, you know? It's like if you bought a Corvette and you were friends with the guys that worked at the Corvette plant. You said, all right, make me the best Corvette you can, you know, tune it up. So that was really cool to be able to do that. So this is the Santa Barbara Mission shot from, it's a picture from Google Earth. So what we do is we set up the tripod and the pan tilt on the sidewalk right in front of this rose garden. And it's about 180 meters from where the camera is to the front door of the Mission. You can see the Mission has these 2 bell towers on it. It's the only Mission in California that has 2 bell towers, and it's a pretty famous building. So those yellow lines are showing you the field of view of the panorama that I shot. So this is the panorama that comes out of that. It was 310 images that are stitched together. So the image is not 310 megapixels though, because in order for the stitching software to do its thing, you give it about a 25% overlap. So in the end, it comes out to be about 200 megapixels, this image. It's 31,000 by 6. So it's a little under 2 megapixels. So this image is just, it's a dream for printing big prints because you can print it at 150 pixels per inch and it's 17 feet wide. So that's a really nice piece of digital art to start with for making big prints. So for example, you could crop just the old part of the Mission, the 18th century facade that you see there, and you can print that out 5 feet wide and it's going to look great. So one of the ways that I've been describing these images too is to talk about the number of pixels per angular degree. So in this case, with a 500 millimeter lens and 14 micron pixels, it comes out to 625 pixels per angular degree resolution. So that's kind of like a starting point for this, and then we've gone to finer and finer resolutions. So this is a zoom in, a digital zoom in on the facade of the Mission, and you can see that there's no pixelation apparent. And I can zoom in even more on the front door. Just keep zooming in on this image and you don't see pixels. It's kind of like in that show CSI where they'd have the license plate, you know, and they'd zoom in on it and they'd be able to read the plate, which doesn't actually work, unfortunately, but this, you could really do that. It's got the CSI effect. So here's some more details from that image. There's lots of palm trees around the Mission. I was hoping that we would see some critters running up and down the trees because there's rats that live up in the palm trees. I was really hoping there'd be a rat like running around up on the top of the tree, but it didn't happen. But there was a guy that was sitting on the front porch of the building to the left of the old Mission facade, and he was looking at me. So that's him with his glasses. His glasses are cold. They look cold. And then the Mission bell tower has these cool lightning rods on the top that remind me of, I don't know if you've seen the movie The Omen, when there's this priest is standing next to a church and lightning comes down and hits the thing and this cross falls and skewers them. These kind of remind me of that. They're cool. They're up on the top of the bell towers. So then we did another image, and I'm the guy that's kind of making this happen, but I've been very indebted to my colleagues at FLIR, including Vache Arabian and Rich Cagley from Toyon. These are folks that have really helped me out with this, and Rich has done a lot of image processing. I want to just give them a shout out because this is definitely a team effort. This is next image is a cityscape, so it's a 180-degree panorama. Ended up being about a gigapixel, and it was shot with 1,568 images that are all tiled together. So when you get up to that many images, it starts to become a long duration collection. So the scene can change during that time. So one of the ways to avoid having the image look weird, like for example, if I started shooting before sunset and then the sun sets and the scene is cooling off, I try to wait until after sunset so that then the cooling is a little bit slower, the rate of cooling is a bit slower, so the scene isn't changing while I'm collecting the data. So here's the view from the patio of my friend's house where I shot this panorama. So I collected the data and then I gave it to Rich and Cagley from Toyon, and he and I did our own processing on it. You can see there's a building out in the distance, kind of a white building there. That's the seminary. So the seminary is about 3,000 feet away from where the camera was set up. This is a visible light image of that that I took with a telescope. So I'll just go back so you can see the seminary in the center. So there's the seminary in the visible band. And then there it is marked on the image. So that's the full image on the top. And then you can see with a 10x digital zoom, you can see the towers, and then there's a 100x digital zoom. So you get a feel for how big this image is. It's just enormous. You could drive around it all day, and there's people in it walking down the street and all kinds of interesting things going on. I wish I could drive you through it, but there's no really good way to do that from the stage. So we printed that out with a wraparound Lightbox prints, and we have this in one of our meeting rooms at FLIR. So it's neat because it's backlit with white LEDs, so you can go up and see it, and it just looks like a photograph, even though it's 22 feet wide. So it wraps around the building. I mean the walls in this room. So about a year ago, or actually, how long ago was this? I can't remember. Anyways, within the last 6 months, I guess, we were going to go to CES and have a booth there. We wanted to have some booth art for it. So me and Vache and David Hodson from FLIR went off to Las Vegas with a new rig this time. This is a longer lens. It's a New England Optical Systems lens that you can zoom to 1200 millimeters. We ended up setting that to 580 millimeters focal length because if I had run it at 1200 millimeters, the depth of field becomes a lot shallower and we wouldn't have been able to get everything in focus in the scene. But also, just it's a matter of scan time because this ended up being 1,800 images, and that took about 2 hours to collect. If we had shot, imagine if we'd shot at twice the focal length, we'd have 4 times the images. It would take 8 hours to collect it, and you'd have this monster data set, and it was already really big. So this panorama is it's a bit wider field of view, and also a lot taller than the Santa Barbara 180-degree panorama, because Las Vegas is just such a rich data set. There's so much going on there. So this is a view from the hotel balcony. So it's the Cosmopolitan Hotel, which is one of the only hotels in Las Vegas where you can go outside on a balcony. I guess that's because they're worried about people dropping stuff down or worse, throwing themselves off the balcony, I don't know, but it's hard to get these rooms. So we found these rooms and we got a balcony suite and set up the camera on there. So here's what the room looks like. So we had the computer set up in there on the table, and we could run the cables out through the door. So this was a really cushy shoot, because most of the time we've been outside and it's cold and windy. This is like the real Hollywood shoot. So that's what the thermal image looks like. It's almost 1,800 images that's stitched together, and takes a couple of hours to do the stitching on this. And it ended up coming out to be about 1.2 gigapixels. So while we were processing it, smoke was coming out of the computer, because there was just even though the amount of data is not that enormous, the way that it does the compositing with this Microsoft image composite editor, I think essentially has like 5 or 6 copies of the image in RAM that it's doing all kinds of optimizations on. So you can see that the 16 gigabytes of RAM in the machine was all getting eaten up. So the operating system was getting slower and slower. So we ended up having to put in 32 gigabytes of RAM to get this image to process. So here's a digital zoom, a 1x digital zoom. You can see the tower on the fake Eiffel Tower. You can see there's a little red box around there. So then there's a zoom in on that detail. And then you can zoom in again on the green box, and that's this. So it's a really cool image, because you can just keep zooming in and all that. And there's just lots of stuff going on in this image. You can see the high roller, that big roller Ferris wheel in the center of the image. There's the balloon, the Montgolfier brothers balloon over on the lower right, which at Paris, Las Vegas. And then Lake Bellagio, which has lots of little restaurants and shops down on the lake. So this is the Flamingo Hotel. It looks like they got some problems with the facade, like some water intrusion into the concrete. So we're learning some interesting things about kind of the decadence of Las Vegas, you know, like which hotels have money and which ones are hurting. They need to do some renovation. There's one of the compartments on the high roller. You can see there's some stitch artifacts in here too. You notice that one of the struts on the high roller is severed in half. That didn't actually happen, luckily. That's just an artifact of motion. Because what happened was we started shooting this image at 10 p.m. and the high roller would move every 15 minutes or so. It would go around. We were hoping that while we were collecting it wasn't going to be moving, but it did move a little bit. If we waited until after midnight, then it stops running apparently, or it runs a lot less frequently. But the problem then is that the scene is really cooling off in that dry desert air. So then you lose contrast. So in the end, you just have to accept that there's going to be some trades on an image like this. So that's looking down at Lake Bellagio. You can see there's like a restaurant there with some space heaters. Kind of a cool looking shot down there. By the way, I'm using a black hot palette. That seems to look the best. So black is hot and white is cold. So it's an inverted thermal image. I've tried color palettes on these, and they only work in certain cases. Like the rainbow palette looks pretty good on a Mission, but if I put a color palette on this, it's just a huge mess. There's just too much high spatial frequency content to make it work. There's a Minion down on a corner. You know, those Minions. I would not want this job, because I've heard that, you know, if you're in a costume like that, like drunk guys will come up behind you and like whack you on the back of the head and then run off, and there's nothing you can do about it. So what we want to do next, well, there's this refinery in Torrance, that Exxon refinery, that is just really, it looks really Blade Runner. It's got all kinds of like futuristic, you know, flames coming out of towers and all these crazy things. I'd love to shoot that. I have to find a business that's willing to let me get up on the roof to shoot it. Exxon doesn't want us to come and shoot. Downtown LA skyline is nice. There's some neighborhoods in north of downtown where you could get some good views. And the good thing is that the camera will tend to see through smog because of the longer wavelength. And then the New York City skyline, I really want to go and do that as well. So that's all I got.